Alright, hello, my name is Loomer Sunil. Welcome back to the channel. Today we're learning about BSP. Like, comment, and subscribe. Sorry about that. I'm doing an experiment. Okay. Let's see. Let me set this up here as usual. Need to adjust the settings every time. There's probably a better way of doing this, but I'm a slow learner. Alright. And Dark Reader is messing up the styling. There we go. And boop, 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 boop. Okay, let's see. Let's continue where we left off. Right, now it all comes flooding back to me. Let's boot this up and see where we are. So basically, we have this circle collision detection going on, but it's not perfect, and it looks like it kind of works for the basic cases, I guess you could say. Yeah, I mean, yeah, but then there are a couple of edge cases here and there, and of course this kind of, if I say this, so when I click on my right mouse button, it's kind of like, you can imagine it's shooting off a ball. There you can see this green ball, which is kind of not really aligned with my Y here, but it's kind of, you know, below where it should be, but it's just showing, the red dot is showing where the intersection would be on the wall, where the ball first hits the wall, and then the ball is like where the ball is when it's like hitting the wall. So you can see it's like right at the wall here. And then we can go around and shoot at different angles here, and it looks like it kind of works, except when it doesn't. So there's a couple of edge cases that doesn't work, and I'm gonna set up a more advanced map later to see to test even more things here. But it kind of looks like it sort of works. There are some weird edge cases here where you can see here that now, for example, the red dot is like showing over here, where there's actually not even a wall over here. There's like not even a line here. So I don't know why this shows up here. This could be that it's calculated incorrectly. It looks like it just needs to be flipped here on the other side or something like that. It seems to be switching for some reason at some points here, like when we're in the middle, it sort of switches around. Over there it goes, actually it kind of rotates. I'm not sure, maybe it depends on the direction of the aim or something, I don't know. But over here it seems to work more, maybe, I don't know. And then also in the corners there's like a sweet spot where it just goes through here. So there we go. Surprisingly, over at this way, where we actually have a split and stuff, there doesn't seem to be that much difference on the actual ball itself, although you can see the point of intersection is changing there. You can see there it's like along the wall. Suddenly over here it's like rotated a little bit. Not sure why that happens, but yeah, I've been thinking about this problem, and I've been looking into like Minkowski sums and all that stuff, The problem with that though is that I really wanted to avoid having to create a whole other BSP tree for that alone, because I was thinking like making a circle collide with some type of convex or just lines basically should be easy enough, but I mean apparently not. So but the Minkowski sum is like, imagine tracing this ball around the wall here, which means also that the like, and you can see here that the ball just goes around like this, right? So that would just extend the wall essentially by, you know, over here. So from here it extends over here. However, at the corner it's a little bit different, because the ball should like, it's gonna like move, rotate around like this. So so that essentially means that we're gonna get a curved edge, which doesn't really fit that nice with the BSP, because you will get like an infinite amount of planes over here, or you will get like a lot of planes, depending on how high resolution you want the circle to be. So I'm not sure about that solution actually. I think I read that Quake actually used like AABBs, but as the player whole, so that you wouldn't get this issue. It would essentially just extrude the walls in a very, you know, in a more simpler way, I guess. Because that's the thing, like if you're gonna use like some kind of complex polygon to act as the whole, you will get a whole bunch of more complex, like the BSP tree will get a lot more complex as well. So yeah, I don't know. I think I just want to try and solve this using this. But but the thing is, like you can see, it works kind of well like this. But then when I try to apply it to player motion and like colliding into wall, there is like, okay, ignore the bumping here, because there's like a correction to which I've like overloaded, overpowered here, so that the bounce back is like very large, so that's why we're going like this. But essentially sometimes it doesn't even detect an intersection. So that's the thing, like we just go straight through this event horizon here, and nothing's happening sometimes, right? So that's not good, and I have no idea what why that happens, and yeah, and here we also get like there. I just went straight through, and it's like this should be like an invisible line around that I can't really pass with my center position as a player, but yeah, apparently that doesn't always work, and even when I try to get back, you can see it kind of bounces off. So that's where we are right now. So yeah, we've been dealing with this for a while. But it's gonna be very nice if we can solve this. I mean, there might be some limitations to this method here, because one thing that I was thinking about is the edges. So over here, sometimes if I aim like over here, you can see the ball is like, it doesn't look like it should get stuck here, right? It looks like it thinks there's a intersection point here at the very edge. It might just be, I'm not sure really why. And also you can see here, if it's like it's on the other side of the wall. Yeah, it's like it's saying that it collides on the other wall, even though it should really collide with this first. So that's also a thing. And out here, it's like it doesn't actually, you know, this intersection point doesn't make sense. I think it could have something to do with how we are traversing down the BSP tree and keeping track of which wall was the splitting wall. Because this wall is the splitting wall, right? And we're kind of moving straight over it, but it shouldn't hit it. Like over here, it doesn't hit. Because... why is that? We should traverse this node. Maybe we don't. I'm not sure. It might be something to do with how we are like traversing and how we're deciding which kind of, you know, circle sweeping motion is being used to compare against this wall here. Right. So yeah, it's a little bit of a mess right now. I mean, I'm almost considering switching my method a little bit, because I'm not even sure what if we're doing is correct. I mean, if we're gonna follow, like we are not following the Quake algorithm when it comes to the sweeping and correction of the position, because Quake actually does several of these sweeps, depending on if you're in a kind of crevice, or if you're colliding against two walls at the same time. You're moving into a corner, let's say. Then it does two corrections. It does like one for each wall. So, and then it also has a crevice fix, which is also like if you're colliding into one wall. If you're going like, let's say you're going, okay. Let me show here. So let's say we have, let's say we have a wall here, like this. The player is here, and the player moves, you know, the player goes in and moves like in this direction over here, like straight like this. Hello, John Anderson. What's up? What's up? So if the player moves straight like this, it's gonna collide with both of these segments. So first, there's gonna be a correction against this wall, which means the velocity will change. Imagine if I'm just drawing the vector here. The velocity will kind of change like this. So it will point upwards along this wall. And then we'll do a second. So if we follow the algorithm completely here, the player would end up at the end of this, because that's the new velocity, right? So the player would end up like up here, let's say. But now we do another sweep from here to here, or from here to here, basically. So that collides with this wall. And then we stop there, because the velocity will basically be set to 0. The position will be adjusted and the velocity will set to 0, basically. So that's how they do it. But there is like an edge case. Hey, yo, Blue, what's up, what's up? There's an edge case if you have something like this, I think. And the player moves up like this. This wall this wall will correct the velocity along the wall like this. Whoops. What's happening? Oh. It will correct the motion or velocity like this. And then you might collide with this wall, which corrects the motion like this. And then you might get stuck. And then you might actually move into the first wall again after this correction here. After the second correction. So you might actually go like straight, whoops, into the second wall or the first wall again. But then there's like a special case crevice fix for this, which I don't remember how they did it right now. But oh, you're switching to Linux Mint. Awesome. Like for your host OS. Yeah. So if we're gonna go with this, we also have to have this kind of crevice fix thing, which I don't remember how it works now, but that's the idea. But we're having a trouble even just going to one wall. So we need to fix this first. And I don't really understand why. Maybe we should begin by trying to fix this issue here with the intersection point being weird sometimes. Over here is a good example. It's like over here, it should be over here. It's kind of interesting that the ball seems to be in the correct position, but the intersection point is not. Although we're not really using the intersection point. However, we probably get like the wrong. Wait, hang on a second. No, that looks correct. Yeah, that's strange. Like, yeah, I don't know, man. I thought there was some correlation here, but apparently not. Yes. Oh, awesome. I hope it goes without any hiccups. Have you installed Linux before? Let's see. I was thinking maybe we should fix like the intersection thing first. I think that the segment is wrong that we're getting. Maybe, and actually the segment isn't even populated sometimes, so maybe that's also the issue. Like you see in the logs it says collision 1. That means that it's like the wall with ID 1. This should be 0 here, so that's the root wall, and then 1 is the next wall, or segment, I think. Yes, segment, because this is 2 and that's like 8. Okay. So you're ready to face problems. Yeah. I mean, the important part is that you learn how to solve the issues, and you have a way of solving them. It's probably good to have. I mean, yeah, nowadays you could just have a phone, search for any issue that you get, and you probably get some answers. Yo, cool guy, what's up, what's up? Oh yeah, Discord. I haven't been on Discord, to be honest. Let's see. I was gonna do your thing there, but I haven't gotten to it yet, sorry. So Code Guy, the link you sent through LinkedIn, is that the thing that you wanted feedback on? There was nothing else. That's the only thing you wanted feedback on, right? Hello, Sadhu. What's up? What's up? Welcome. And then there was also the other guy or a person who wanted to get help migrating to like NeoVim or something. Sandeep. So if you're on here, I'm not sure what your nick is on the stream, but if you're here, we could go through it on stream if you want, or I can. I'll send you a message on Discord today, and we can take it from there. Unless you want to take it on stream, if you're here, that is. I don't know if you're here, but yeah. Anyway. How bad can Mint be? I've heard it's the most simple and the stable distro. Yeah, I've heard it's good. I think I used it at one point. I've used Gentoo and Arch, and I think when I started I used OpenSUSE or whatever how the name is pronounced, with the gecko, I think mascot or whatever. That was a long time ago. Like nowadays, I have no idea. Like the one that I'm using now is very specific for this specific setup. So I'm on Windows as a host, and I'm running WSL. And the Linux operating system on WSL right now is Ubuntu, the terminal-based Ubuntu OS. So, and it's just because it has like. I mean, I guess it has support from Microsoft, so it works pretty well through this setup here. And I'm only using the terminal, basically, so. But yeah. I watched like a Linux distro tier video by someone. I don't really know too much about it, but it really, I guess it depends on what you want to use it for. Gecko mascot, iguana mascot. Yeah. Oh, is that what it is? Iguana? I thought it was like a crocodile. Wait, what the hell is an iguana? Zig mascot. Oh. Or an alligator or something, I don't know. What is it? Iguana. I mean, it kind of looks like a crocodile in the drawing, with the mouth and the tail. I don't know. I mean, it's kind of short face, mouth, nose, but yeah, whatever. Maybe it's like a crossover. Yeah, so the collision message tells us which segment we're colliding with. Sometimes we don't get a segment at all. And I am very, very confused as to why we don't get any information about the segment. I think what we're gonna do is we're gonna do this to see if we get a collision at all. Collision detected. However, we don't have any information, so let's see if this triggers that at all. Okay, it didn't actually trigger. You can see we always got a pair of detected and collision, so it always went through there. So that means that we don't even get here if we don't have a intersection, which is strange. And it doesn't seem to matter which direction. It's like even if we just move forward, sometimes it hits, sometimes it doesn't, and I have no idea why. And that all seems to, but that, I think that's a good sign, maybe that. But anyway, Osig has multiple alligator, iguana. Oh. Mint is lightweight. Yeah. I don't think I'd ever. I will probably never, like, unless something drastic happens, I will probably never install like Linux on my host, because I want to be able to play games basically. I think this works really well, like having Windows on a host as my host, even though, you know, I really like, you know, being able to configure stuff, you know, of course in Linux, but I really, you know, rising and stuff like that is not really my cup of tea. I mean, the thing that I'm interested in for Linux is development, like using it as a development platform basically. And I really like to have the tools that you get from, you know, the terminal and you know, NeoVim. Being able to use this here and all the tools. I know that probably you could do a lot of stuff with PowerShell and stuff for now, but yeah, I'm probably never gonna learn that. You can play games, most of them. I mean, I don't think so. I don't know. Can you play, like, if you go on Steam? I know that Steam had some like thing many years ago where it's like, well, now, you know, we're allowing Linux games or whatever, and or Steam is on Linux, but it's just the games that are actually compatible that you can play. And the ones that didn't, you could run, I guess you could run like Wine or something, but I mean, there's a whole bunch of compatibility issues there as well. So it's like, I don't know. I don't want to take the chance and run into a whole bunch of issues, you know. Valve has a compatibility layer. Okay. Well, I mean, to be honest, I haven't tried it because I haven't installed Linux in I don't know how long. But then it's not only Steam, you know. There's games on other things as well, so. Like, I don't know, it's actually, you know what? Like Hearthstone, like Blizzard games, are those because I know that Hearthstone is available on Android, and Android is a Linux-based system. I mean, Mac is also like Linux-based, I guess, as well. I'm probably not gonna do a gaming channel though. Like, I don't think I'm. I don't think I'm like, you have to be entertaining. So that's probably not gonna happen. You know, I'm trying to show like programming stuff because that's what I'm like interested in, and well, I mean, I guess I'm interested in games as well, but man, this problem. Okay, so what is going on here? Mac is Unix. I'm not sure if Unix even. I don't know if it even exists anymore. Unix wasn't that like a. Is it? I mean, yeah. I don't know. I don't know. I just know it's very old. It's like, I think that if I were to play games, like, I don't even know how to like what to talk about. Like, I'm not really good at. I think what I'm trying to do on this channel is to provide, you know, education or whatever, like educate on programming and stuff like this. Like, it's not really about entertainment, I guess. And when playing games, it's more like you have to be. It's not like you're only like playing the game. You have to kind of, I guess, I don't know, talk about things that has nothing to do with the game. I don't know. Or just be entertaining about the things that happen in the game. I don't think I can do that. Are floating numbers bothering you? So, I don't think so. I mean, they seem to bother me a little bit, maybe, now, when we get some precision errors. Educate on games. Yeah. I will leave that to the speedrunners. Alright. He's like Terry Davis. I'm not sure if that is like. I mean, that could be either a very nice compliment. It could also be something else. I don't know. So, okay. The thing is. Okay, I'm gonna try and log out the path that we're taking. But we only want to show the path. This is the hard part because we're gonna get spammed. And the cases where it fails, it's gonna look like like any other case. So that is not great. let's remove this. Let's get rid of these things that we didn't have. I guess, well, the acceleration stuff, but we do have the information there. I think we'll get rid of these things. They're not really used. Okay, I'll go through here to see if there's anything weird going on here. Here, we're kind of cheating here because we don't consider the acceleration here. We only consider like a velocity. Maybe that's like part of the issue. I don't know actually. We only consider velocity, which we do calculate. So basically what we're doing is we already calculated an end position, which is the start position is the player position. End position is like the calculated where would the player end up in the next frame. Maybe it's like too small of a step or something. And sometimes it just goes through. Like the velocity is too small. I mean, we don't really need this, but this was just a shortcut to see if, okay, well, is the velocity very, very small, like basically 0, then we don't really need to check this. Like, I'm not even sure exactly how to figure this out. I think one thing we could do is have a sub-step. Okay, maybe that was actually it. Okay. That was an easy fix. Let's fix this overbounds. Do like smaller step there. Okay, right, so the corner is a problem still, but let's try the normal case. There you go. Wow. So the corner is a problem, but this works. Oh my god, I can't believe it already kind of worked. So the corner, you can like just go straight through the corner. Is it a feature or a bug? You tell me. Okay, so why is that happening? What does it tell us? We don't get any collision detect. Like we don't get any collision. Information at all. That looks kind of trippy with this texture here. I can kind of go in here and then I probably won't. Cold guy. I mean, it would be nice, you look at all these streamers or YouTubers who like make a living by playing games. I mean, of course you have to put in some work as well, of course, but could you have a better job? I don't know. Instead of sitting around shuffling some things on a revolving line. Okay, cool. So Okay, so what's up? What's the deal with these corners? Oh my god. Should I try to pronounce your name? Hatran. What's up? You're watching at work? Great. I'm just gonna refill my coffee. 1 second. You don't get fired. I mean, it looks, you know, right now it's you're looking at some code. That doesn't look like you're watching a stream. Okay. you could I mean, you can say it's for educational purposes. But yeah, you probably don't want to play with the fire. How was the pronunciation, by the way? I should have dialed it up. Okay. What should we do? What should we do? Okay, let's just go through and... because I don't really have a good idea on where to tackle this issue, but I'll just go through to... go through the code yet again to familiarize myself a little bit. So we have the velocity. At the end, we would be either in a leaf, and we would be either in an empty node, where nothing happens, or in a solid where we get the intersection point. Very, very good. Most important is this though, this position here, and the node. That should all be good. Yeah, denominator. I think this should all be fine. And if it's close, if it's like 0, then we are basically parallel to the wall. So then we just check, okay, which side are we on? Choose that side and continue down that side. Like, we're not parallel. We're not moving parallel if we're moving into a corner. We're moving like 45 degrees or something. Oh, nice. I think, well, I don't know, but you're the first that admits that you're a Vietnamese. At least. I usually get people from like East, or not East, well, wait, what is it actually? Is it Central Asia? Yeah, it's Asia, basically. I mean, Central East, Central or East maybe, because of the timing of my streams. Because right now for me it's like, I started at maybe 10 or half past 10 or something. Now it's 10 to 11. And over there now it's like evening. I've heard. That's how time zones works, I think. So I just get viewers from the East, basically, and a couple of others as well, but mostly from like India. About 4 p.m. in here. Okay. So a little early maybe. Because it's like, after work it's probably better if you want to reach more people. I don't know. Wait, so, okay, I'm so bad at the geography over there. Is Vietnam... it has to be to the east. No, wait, is it? I don't know. How is it in relation to India? Or where is it, I mean? Because I was so bad. I thought that Bangladesh was like to the west of India, but it's actually to the east, like northeast. So I was a bit embarrassed by that, but yeah, because we have people from there as well. Nothing but Buddhism. I mean, on the map, like geographically, like which direction is it in from India? Because in my mind, somehow I'm guessing like it's east of that, but then the time zone would be, I don't know, different, I guess. Okay, we've got the numerator, radius, the start position. Yeah, so this is basically, this here is the distance from the wall, and this is the radius. So this is like kind of encoding, like if we're, how close are we to the wall, are we past the wall, whatever, which side are we on the wall as well. And this is now also like turning that calculation from into a ratio between 0 and 1, and where less than 0 means it's behind the wall and more than 1 means it's in front. Oh, it is east. Okay, good. Then my mind map is correct. You don't want to set the timestamp. I think you usually set it based on the city. So if you find your capital, I think, if I'm not mistaken. Or if you know that maybe do you have multiple time zones? Because we in Sweden only have one, so it's easy for us. But some countries have multiple. Or you could just look it up based on where you live somehow, I guess. You should probably be able to Google that. Okay, so if we're in between, this means we're colliding, and apparently, I guess this doesn't happen then, or we end up in an empty leaf. Maybe we should draw this up. Right. No, not that one. Let's see. Let's do this. Let's take these, cut them out, paste them. Wait, what the hell happened? Oh, did I have the wrong thing? There we go. Cut them out and paste them in. Move this. Okay. Right. Now we have our basic map here. I'll just clean this up a little bit. Okay. And then we have our dear old arrow. We'll move you over here. I kind of like how GIMP 3 or whatever has this where if you move something, it kind of knows which layer you're moving, so you don't have to switch the layer. You can just move the thing. This is in a different layer, so that's really, I really like that actually. And then we have this arrow as well, which we could probably group. So there we go. What happens now? Okay, so it still doesn't move the, it doesn't move the group though. Oh, if I shift move, it moves the group. I see. Cool. Vietnam's capital Hanoi. UTC +7. Okay. Yeah. So, so what we're doing in this project is we're learning about BSP, which was like an old, you could say, like algorithm used in Quake for like partitioning the map in a binary tree in such a way that you could use it to optimize things like rendering and collision detection. And so right now we have our BSP tree, and we're trying to apply it or use it to be able to collide with the player against the walls. And as you can see, can you see this by the way? No. Here, it's we're currently we actually have this collision working, but there's an edge case, and that's in the corner. So the corner we don't actually have this collision, and you go in and the game crashes basically. But yeah, so that's the thing we're trying to figure out right now. So the BSP, it's a little bit complicated, but I can try to explain this here. Yeah, so here is like the finished BSP kind of tree. It looks like this. And let me go through this in steps. So how it basically works is that first, let's hide this player. First you have a list of these segments. So the map that I'm doing right now, I'm doing a 2D BSP version. Quake was using a 3D version, but I'm doing a simpler version here. So how it works is the map is defined. It's a 2D map, so it's basically, you know, Doom was also a 2D map. You could view it top down, and it was actually just a 2D map with a bunch of lines. That's it. Like all these lines make the map out, and then you could have like different properties on the lines, and you have these connecting to a sector, which you can have properties on the sector as well. But never mind that. We're in this game, or this demo or whatever, this learning project, we only have like, you know, lines. They don't really have much properties. So they're basically we have like a starting position and an end position, and then like the direction that they are facing. So the idea is that if you stand over here, these two walls are kind of facing you. So you would kind of have them in your view, right? But these two walls are not facing you. So you could skip like drawing those walls, is the idea. And the BSP will help you to understand which walls are facing you and which walls are not facing you. Like that is one of the like applications you can do with BSP. So how it works is that here you can see you have a level of 4 lines. So we have 1, 2, 3, 4, and basically you can start with any segment, any line, any wall here. So we start with this wall here. Now, how the algorithm works is that you pick the wall, you split the whole plane, the whole space. This is an infinite line, into 2 sides. So you have the front side and you have the back side. So it's a binary partitioning, binary space partitioning. That's what it means. It divides the whole world in 2 at each step. So, and you have a front side and a back side. And direction is important. So we know which direction is the front and which is the back. And in this case, there's what we do then is we take all the other segments and we try to figure out which segments are in the front and which are in the back. Now you can clearly see here there's nothing in the front, so this is going to become a leaf, which is empty, because there's nothing in it there. And empty simply means it's like an open space. There's nothing in it. So there's the 2 kinds of leaves. There's solid and empty. If it's solid, that means that, you know, it's a solid space with that you can't pass through. But empty means it's non-solid. Like, yeah. And then we have these 3 goes into the back list. But they are not they're not like, all of them are not children of this node. So this becomes the root node here. But you only have 1 front node as a child and 1 back node. So the next back node that we would do is I think this one. So we just take one of the nodes, and that will become the next child here. So this is the back child node of this node. Okay, so this we do the same thing. We split the entire space, and remember it stops here because essentially you can think of this space as being isolated at this point, because we've divided the whole space in 2. This is like its own kind of dimension here, its own like space here. So really this line, it only goes like this. That's the whole, but it really is an infinite line. But since we know that we were like on the back, we don't care about the front anymore. If we were to okay, well that's later anyway. Now we have this thing here, and we can see that there's nothing in here, so this becomes an empty leaf. But here's 2, so they end up at the back as well. So next is this thing. This wall becomes the back node of this node here. So you have now the root node, which has the front child is empty. The back child is this node. The front child of this node is empty. The back child is this node, and so on. The front child of this node is empty. The back child is this node, which is the last node here. So it would have the front child is empty, but the back child is actually solid at this point. Yo, abbreviated. So I thought you already done binary partitioning a while ago. What's happening now? Yeah, I mean, I got stuck in it, basically. So basically, okay, I can show you here where we are with it right now, because I wanted to not only to just build a tree, but also to use it to apply different things. So right now we have, for example, you know, you can intersect the walls, and I'm using BSP to kind of you know, understand where we get the intersection. So if I press my left mouse button, you can see that there's a red dot that, you know, ends up on the wall where it is. So I'm applying it to different use cases. So that is one use case, and then another use case is player collision as well, which we do have now. So so there you go. We're using it to collide, to check which walls are, yeah, for wall collision as well. But there's an issue right now where you know, if you're in a corner, it doesn't work, and it eventually will crash when you go into it. So that's what I'm trying to figure out. I'm just going through how the BSP works here for some new people here, and I also wanted to go through this case here because I wanted to kind of understand how we can get this edge case here. Yeah, so what we've done is like build a BSP tree. We have a raycast algorithm for if you have a line. Let's see. Let's take no. Well, let's take this one. Oops. Layer to image size. Okay. So if we have a line that goes from here to here, we can get the intersection point here. So that's an algorithm that we have. That one I showed with the red dot. The other algorithm that we have is that I'm working on right now is if you have a circle, and the circle wants to move somewhere over here, and then it calculates where the circle should get stuck on the wall. So that's what we're doing right now. And the circle is the player, of course, but it can. I'm gonna extend it to things like, you know, I guess projectiles maybe, or monsters and stuff like that. Because I wanted to not just like learn about the BSP, but also go a little bit deeper, not just the surface level. Okay. So what we are actually doing here right now is, well, we can keep that. So if I can explain how the line intersection works. So let's say you have a line, a raycast like this. What you do is you look at both of these start and end points, and you see that, okay, are they in front or behind this root node? So you start at the root node. And you can see that both of these points are at the front side of this root node. So then you would go and cast this ray kind of again against the front child of this node, which is empty. And as soon as you reach an empty, you know that, okay, well, we don't have an intersection because there's nothing in here. So then this results in no intersection. Okay. But if you are here, let's say you cast a ray like this. Now this ray is also like inside one of the leaves. Actually, you know what? Let's do this because this is more an easier thing because it's less iterations. But basically, we can see that we start at the root node again. Whoops. We start at this root node, and we see that both of these points are now behind the root node. So that means we're going to go into the back node of this. And the back node happens to be this node. And then we just repeat. And then we can see that both are in front of this node. But this is empty, so there's no intersection here either. Okay, good. Next up is this one, which is... so the same thing here. You check against it, both are behind. Okay, now we're on this node. Both are behind. Both start and end points of the array is behind this one. So we go into the back node here, which is this one. This is the next one. Both points are behind. Okay, so we go. Now we check against this node because that's the back node of this, and it's kind of hard to see the relationship of these nodes, but yeah, this is the back node, the last back node here, and we can see that both points are behind this node, so we check the behind. Now this behind node is actually solid, which means that this is the intersection point because we pick the start point of the array. So that is two kind of scenarios, or three, I guess, or whatever, how many. The way you do collisions is by doing real-time raycasts. Yes, using the BSP tree as I'm showing here to optimize in an optimized way to find the intersections. Okay. However, what if you do something like this? You start at one point at one side and end at another side. So that is the third kind of scenario here. You have one scenario where you're both in front, another scenario both in back. This scenario is when we're crossing this line here. So again, we start at the root node and we see that, okay, we got one. We check, are they both in front or are they both in the back? They're not. One is on the front, one is on the back. So what we do is you kind of split, you calculate the midpoint and you make two new lines. So you split this line into the start section and then the end section. So you got two lines now, two raycasts. And then you compare this against the front node because that's the side we're on. And that's empty, so there's no intersection. You compare this side against the back node, which is this node over here. And then you go through the things as usual, and you can see that we're eventually going to end up in this empty leaf, and there's no intersection. So this one is, there's no intersection of this as a whole. And important here is that you want to check the result of the start first, because because the array starts over here. So if there's an intersection in this side, then we're gonna use that instead of anything here. So we're gonna check this side first, and if that doesn't end up in a intersection, only then we're gonna check the back one. Okay. Okay. So what if we have something like this? This is the last thing here. So we kind of end up like this. Okay, so this again, this becomes array that we're comparing to the back node. That's empty, so there's no intersection there, and that gets basically deleted there. You can see, and then we go the same way. So we're behind this one, we're behind this one, we're behind this one, and now we have, this is a solid, so we're gonna take the starting position of this array, and that's the intersection point. And there you go. Yeah. So that is how you can get the intersection point of. And if we disable this, if we hide this this BSP, you can see that we actually got, we get the point on the wall that we are interested in. So that is how the array intersection works. But now, so that actually works, and that works flawlessly, basically. I've left out a little detail about how to structure the BSP tree, but we don't really need to worry about that right now, because that's actually not relevant to this algorithm here. But there's the BSP tree is a little bit more complicated if you have more objects in the scene that kind of splits the plane. But it doesn't really matter for this thing here. But now let's say now we have a player that wants to move in like this. Actually, I want to rotate this. That looks bad. Let's just do like this, like 45 degrees, basically. Okay. Oops. So I want to move like this. Now, okay. So also so I've shown you the raycast algorithm, although I'm not sure how clear it was, but you know. But now what we're using for the player is actually not the same algorithm. We're using a sweeping circle algorithm. So you can imagine this circle here, and it's kind of sweeping along this velocity vector to end up somewhere here. And then we need to find, okay, where are we actually colliding with the walls here? And if we take the easy one first, if we sweep along here, so start here, sweep along here, we need to find this here. So what we're doing is kind of the same thing. We're beginning at the root node, and we're seeing if this sweep crosses the node, and it does here. So that's basically the thing, and the math is a little bit different as well. But you basically have to check against the circle, like the distance between the circle and the wall, and we can see that we approach the wall, and then we have to find the moment at which the collision occurs, and we do that. However, the problem becomes, I think, when you have like two at the same time, maybe, I'm not sure. In Quake, there's actually there's a, well, I have this drawing over here. Here, in Quake, they have kind of the same thing where you have this circle, or actually I think it's like in Quake it's an AABB. I'm not sure, but it checks against the wall like this, and then there's also like a correction. So when you move against the wall, you have, this is the initial velocity vector. The velocity vector gets corrected and ends up like something like this, because we're sliding against the wall upwards. Okay, but then there's another wall. So in Quake, they actually do two checks. First, they do a check and get like the first wall that you collide against, do adjustments against that. But then you might actually slide into another wall and go through it. So what they do is they do another check with a new velocity vector. So they basically just replace the old velocity vector with this one and do the check again. At this point, we're gonna collide with the north wall here, and then there's an adjustment again, which means that because this is like straight on the wall, so the velocity vector will become 0 basically, and the position adjustment will put us like in the corner here. How to make money without job and freelancing? Do you mean without a job and without freelancing, or do you mean without, like, just doing freelancing? And the answer is, I mean, you will have to make something yourself that you sell somehow. Okay, so that's how Quake does it. And we don't really do that right now. I'm not sure if that's the issue though, because we just go straight through. Like I would expect to hit one of the walls and have that, but it doesn't detect any collision at all. So I just wanted to go through the theory a little bit to kind of understand, okay, how could this happen? Hey, Mycon, what's up? Welcome back. Oh, a gangster. Okay. Yeah, I guess that works. The competition might be tough, though. All right. Or you can move to one of those isolated civilizations and become like a god or something. That also works. Okay, let's focus here. So, right, so we're gonna start at the root node. This is gonna sweep along like this, and obviously this is gonna go through this line here. So another thing that we're doing is we're keeping track of the last node that we actually passed through. So that's the last split. So this is equal to 0, which is the root node. That's 0 there. Okay, and then you end up basically with well, it's gonna like move the circle along the line like this until we hit the wall, until we hit this splitter, and then this becomes the new start position of the next check that checks against this thing here. So that it's kind of different from the Ray version, because the Ray kind of assumes that we're in the node, entirely in the node, and this it's kind of that we're in the node. It's like the first point where the circle touches the node, I guess. So it works, but then at some point we're not gonna collide against this one, we're not gonna collide against this one, but we are gonna collide with this line. So that will also, now this line is the last split. So then we have a new, can I like select a select a layer based on where I press? I don't know. So at the next iteration that the last split changes, last split will actually become this one, which is like, I guess 1, 2, 3, 4. Okay. And I guess the position doesn't really change, probably. And then we should get a collision The thing is, this point is like behind, or I mean in front. Maybe that's the issue. But the end point is behind though. So we still should get like a ray that goes behind, and then the start position is the intersection point. Sounds like algorithms designed for 2D works. Yeah, so I tried to explain earlier, like the Doom, you know, the Doom game, it's a 3D game. Well, it's kind of pseudo 3D because the maps are actually page up and page down to select the days. I didn't know that. Thank you. Doom is actually like a 2D. The maps are 2D. So in the old school Doom, like you couldn't have a room on top of another room. That was impossible in Doom. What you had to do is make like, you could hack it by having like a teleporter that like teleported you to like a simulated, you know, upstairs or whatever. But you couldn't have two rooms on top of each other because of how the map was defined. And I'm trying to do the same thing here. I'm defining the map as a 2D map that you see from top down in this view here. So this is a 2D top-down view of the map because it simplifies, you know, everything basically. I wanted to make a simpler version of the BSP to understand it, and then it could be, you know, extended into 3D. But there's probably more things to worry about in 3D though. Maybe, I don't know. But anyway, so I don't understand why this would be not actually working. Just from this here. And we don't get any recorded collisions either. So it's not like we get a adjusted velocity either. Yeah, that's the thing. Like, I would expect... I mean, okay, actually, you know what? The thing is, the vector doesn't actually go this far in real life. It actually just goes probably something like, you know, something like this. And that would mean... or you know what, even further than that, it probably just goes like this. You can't really see it, but oops. Actually, let's just delete this layer. Okay. So it probably just goes something like that. Which makes sense because the ball here, the player circle, will end up like that. Okay, but then what the point we're checking is actually on the back, on the front side of this node. However, it touches the back side. That's the thing. So it's like if the point is, I mean, we're checking if the point is in front. We're not checking if the entire circle goes beyond. I think that's the issue. Are you using something like Photoshop? This is GIMP. It's open source, I think. Free. Well, it is free. Free, you know, drawing program, kind of like Photoshop, but it's, you know, it doesn't have all the bells and whistles like Photoshop does. But it is a very nice program, and it also allows you to build plugins. You can use like Python, something like Python, and I think Lisp works as well. Abbreviated knows a lot about that. But yeah, I think that's the issue. I think when we check if we're in front or back, we should like split the ray or the circle sweep. We only check the center. We don't check the full extent of the circle. But the problem is though, no, we're only interested in the node at hand. So we probably want to duplicate the cast then to both the front and the back. And do the front first and then, yeah. Okay, I think that's the issue. I think so. So here is the code for detecting if we actually intersect the line. And then we check like, okay, are we on front? We only concern ourselves with the starting position. Yeah, that's if the starting position is on front. We need to do a little bit more here. Okay, I need to think about this a little bit. I'll just BRB 1 second here. All right. All right. So this means that we have 1 point on either side, or technically it doesn't have to be on either side of the node. It actually is just if the circle goes through. And then we check if the starting point is in front. Then the starting point will be on the front, and then that will be on the back. We check if the starting has an intersection. And then we check the end as well, which starts from the mid. Now that actually, is that correct? So we're on the root node. And it would go from start over to end, something like this. And the split would happen something like here. So that would be on the front side, which would lead to nothing. And then on the end side, it would kind of go like this. And you would start here. So we go from here to here. And this would be the last split. And then it goes through here, this one, both are behind, so we go to the back node. This one, both are behind, so we go to the back node, which is this one. Here we check, do we pass? I think we always check if we pass first. So these are the leaf checks. This is checking if we're going parallel to the wall. This might, or if like either we're going parallel or we're very, very slow. Which did happen. We saw that we actually went in here a lot. What does this actually produce? Machine epsilon. How low is this? $23. Well, I mean, we could understand that it's very low, probably. It could be an error in here that we're only checking one side while we should check for more. The problem is this calculation here. This kind of says that the denominator is basically 0. So this calculation will be kind of maybe off the because of floating point precision. So I mean, we could check if the end circle is different than this side here. So we say that, okay, well, the start point is on front, the end point might be behind, or it has like intersected. So that could be okay, we split the line if we have passed it here. And here, I just want to double check if this is actually correct here. Because essentially, I think this should just be correct. Yeah, I think this is the thing that we need to do. So we're gonna get this. We're gonna get this distance, end distance to line, which is the end position subtract some point on the line. This is how we calculate the distance to the line, and then we dot product to the normal. So this gives us the relative position to the wall. This creates a dot product to the normal of the wall, which then determines in the end the distance to the wall. And then, I mean, we can divide by wait, what could we, I guess the radius. Yeah, or we could just check this immediately. So we could just say that if the end distance is less than or equal to radius, then this means that we are well, actually the sign should be different. It's depending on if we're in front or behind. When you merge this code. Oh, sorry. I totally forgot yesterday. Oh, I don't want the env. Notes, we can remove that. Okay. I'll do this. I'll just check if this still works, and then I'll push it, so I don't forget. Sorry, I'm very forgetful. If you've not noticed that. So let's add that. Okay, there we go. It's pushed. What's an env? That's a secret. You know, you usually have a .env file, especially if you work a lot with web dev. I don't really know about others, but you usually have a .env file for personal tokens and stuff like that, like for APIs. I think I have a token for, I think it's for GitHub or something like that. I don't remember. I can actually open it with NeoVim because I have I have the cloak, so I can open it without showing the. There you go. It's secret. Yeah, it's the CLI token for GitHub. Yeah. I don't remember what I used it for, actually. Maybe I copied it over from the last project just in case to have it. I think I wanted to use it to create a repo from the terminal or something like that. Yeah. All right. So. Right. Yeah. So end distance. It's pushed now, by the way, so you can go ahead and check it out if you want. So end distance. So if this is happening, I want to have an agnostic way of looking at this depending on which side we're looking from. But this essentially only works now if we're in front of the wall and not behind the wall. But yeah, we have to fix that later. But let's continue here to just finish the algorithm. We can adjust that later. So if we're past the wall, if basically like this, if the end node or if the end position is circle, if the end position's circle has passed the wall relative to the start position, then what do we want to do? We want to basically split here as well. This one just picks the front side if we're on front with the start position. But what we want to do is check first if this collides. If the front part collides, we get an intersection point and we return that. Otherwise, we do the same trace and we return actually now this becomes a split, so we should update the split here. And this would be the start side, and this would be the end side. There we go. And here we need start side, end side. This one we don't need until we're down here. Okay. Now, the only thing that we need is to understand if... Well, I think that this normal needs to be like negated based on if this is on front, this should not be negated. If it's not on front, this should be negated. So we could say if is on front, then we just use the normal. Otherwise, we will use the normal negated. I think that could maybe work. Okay, that works. That does not work. Okay. God damn it. Do you consider your code base as a good influence for beginners who want to read code and learn from it, or are there any bad practices in it? I would, let me say like this. I haven't taken that into consideration. I'm basically just programming as usual and trying to get stuff work, basically. So, I mean, don't take it as like a super intuitive or beginner friendly code. It's I have not taken that into consideration. So, but I mean, when I program, I try to, not just for me myself, but also for others to have some kind of standard. But not always. Sometimes you just want to get something working and you do a bunch of hacks here and there. But and then sometimes you do a little bit of refactoring. But this code is like it has everything basically of that. So you have hacks, you have some refactoring, probably not a lot. So yeah, what you're looking at is, I mean, you could say that it could be a good representation of a real life project, because real life projects are not always up to par with coding standards, because sometimes you just want to get something to work, and sometimes bad code slips through the code reviews. Do you add multiple nested loops? Sometimes, if the algorithm needs to. Like, multiple nested loops, I would say I would probably, that's very limited use. I would probably only use that if I'm dealing with like a multi-dimensional array or something like that, and I'm trying to kind of either like traverse that or do something with that. Like, let's say you have a 2D grid of pixels or of something, and you want to loop through everything to, I don't know, to do some kind of pass on it. Then you would have a nested loop of 2 loops. One for X and one for Y position. In some cases. You can also just use one loop though, because you could just loop through and then calculate X and Y based on an index. If you have like the width of the grid. So this is how most small companies' code base look. I mean, I'm just saying that probably like real life code, like projects, don't usually. I would say if it's a long-lived project as well, you usually have. Well, I say usually, but in my experience, if you have a company that doesn't really like, usually they don't really like refactoring because it takes time and the leadership doesn't really see a point to doing it. Like it's basically just a downtime cost of development. So it just takes time and you don't get anything, you don't get any features out of it or anything like that. But what they don't understand is that, or yeah, they think they're getting fooled by the developers who say that if we don't do this, then it's going to take longer to make more features because it's a mess right now in the code. And if we want to add more features, there's examples of projects that have died because of how bad the code is and how long it takes to add new features, because they never like do any kind of maintenance or anything like that to the code. So just to add one little feature that seems very small and it probably goes very fast in a modern project or a new project, it takes like weeks to do in one of those old projects that never was tidied up or anything like that. But you're probably gonna see like a lot of different projects as well, to be honest, like because some companies do value having a good quality standard in the code. And I mean, it all depends on the teams that actually do their project. And a little bit on the leadership and stuff as well, but yeah. So you're probably gonna see a lot of variation. I'm just saying that, you know, it's not all sunshine and rainbows in real-time projects or real-life projects out there in the wild. But if you have like an open source, I would say probably that's where you probably want to have really good coding standards, because of, yeah, then you don't really have, I don't know, deadlines, stuff like that to make something work, I guess. As a beginner, I struggle with time complexity, but it's not a big deal because computer is faster. What do you mean time complexity? Like, do you mean estimation? Like estimating how long a feature will take or to implement? Or what do you mean? Or do you mean like computationally how long an algorithm will take to run? Oh, big O. Okay, so how long it takes for the algorithm to run, basically. Yeah, I mean, yeah, I struggle with that as well. It's just, I feel like people put too much into that notation. It's quite, I mean, if you're programming, you can kind of intuitively understand if it's going to be like, yeah, the only thing you have to kind of, you just learn how that works. It's just, I don't know. I think people talking about the big O notation, like, I think it's just sometimes it's just confusing if you have like, yeah, it's n times log n squared plus n, you know, it's just confusing sometimes. Like, the only thing that matters, I feel like, is if it's like, okay, is it n squared, is it, you know, n, or is it log n, something like that. Like that, it's only a meaningful distinction. Like, it's only, and also it's like you don't really need to think about optimization that much when you're building a new project. You should not think about optimization at the start. You should just build the project to make it work first, and once it's working, then you can think about optimization if you have the need for it. It's not always, and there is a need for it. I mean, if you're interested in it, in that kind of stuff, then by all means, you know, go ahead and you know, be interested in it and learn things about it. But if you just want to make something work, then optimization is unnecessary most of the time. Do you struggle with cache misses, like writing structs? Like while writing structs? Cache misses? Are you talking about CPU cache? Or... because, you know, you don't actually have to worry about that. Unless you're building something that needs optimization. Then you could worry about that. Like, for example, if you're building a physics engine for a game engine, then you have to worry about optimization. But most of the time, you know, it's not really, it's not, I would say like this, it's not a general worry when you do generic programming. It's only for certain, it's only needed for certain systems. Games need optimization, yes, but only if, you know, only if it's a problem. You know, you don't need to go and optimize every little thing just because. And as John says there, avoid premature optimization. So just make the game first. If it lags, that's fine. If it lags too much, okay, maybe you should. It becomes a trouble actually trying to play the game. Then you could look into optimization. And if you want to polish it at the end, yes, probably you want to optimize it a little bit to make it work, you know, make it run smoothly. But then there's like there's a limit to where you say, well, now it's good enough, so let's stop there. I think in the beginning, when you're learning programming, you really don't have to worry about optimization. The things you should focus on is trying to figure out the algorithm that works. Learning about basic programming tools to make to kind of learning about how to break a problem down in smaller parts, things like that. Like optimization it feels like such a late stage thing. So that's what I would say. Now this doesn't work. So okay, so the start, so this should calculate if the start is on front. And this calculates how far we are, how far if the end position circle, or how far the end point is to the wall. And it also flips the sign based on if the start position is on front or not. So we're basically trying to say, like, if we're on front, we're trying to look at we're looking at the distance from the front. Otherwise, we're looking for the distance from the back. And if the distance is less than or equal to the radius of the circle, that means we have now passed the wall. I think this is what maybe doesn't work, or I'm barking up the wrong tree. But yeah, also Blue, I would say, like, if you're a beginner, also, I mean, you could look at any code. You can inspect any code, I would say, as a beginner, and try to see if you can understand it. Unless it's one of those weird, arcane, you know, the Quake 3 thing, the inverse square algorithm or something like that. That is probably not a productive algorithm to look at. But, you know, just usual projects out in the wild. You could look at, like, you know, GitHub code, any kind of project, and go in and just examine the code, see how other people are writing the code, and, you know, you can kind of like analyze it and see, okay, well, this looks cool, I kind of like this, or I didn't know you could do it like this, or whatever, you know. Pick up things here and there. I also struggle with allocating objects, like which one I should put on heap, which one I put on the stack. How do I structure my code? Because my brain is too small to visualize the whole project. I don't think I don't think it has to do with the size of your brain. I think it has to do with how you've trained the brain. The longer you program, I think the more you train your brain to kind of keep more of this stuff in your brain. It's like driving a car, like learning to drive a car. Like in the beginning, there's too much things happening, so you basically you have to focus on everything. There's nothing going on. There's nothing like delegated to the back of your mind. But then when you learn to drive the car, basically everything happens like subconsciously almost. It's the same thing. It's just a matter of training. And regarding like what to allocate on the heap or on the stack, like, I mean, it depends. Like usually you put things on the stack that are kind of temporary. If you have a function, all the local variables are put on the stack, you know. If you want to return a struct or like an array, you probably want to have it. It depends. Like in Zig, you can return a struct and populate it. It's like the only you could put things on the heap as well. It's like the stack is, I would say, is not really used to, like the heap is used to store larger things, while the stack is. Do you program unconsciously? Yes, sometimes. I mean, sometimes my brain works on a problem without me kind of actively thinking about it, and suddenly a solution pops up. If I'm doing something entirely different, maybe I'm out walking or running or something, and then all of a sudden my brain just kicks in and gives me a solution to a problem. Or sometimes I dream up a solution to the problem. But that's also like allocating objects on the heap or the stack. That's also something that you learn by over time. But generally, you know, temporary things on the stack, dynamically large things on the heap. Like if you want to have a dynamic array that you need to, you know, modify the size a lot, then you probably want it on the heap, I guess. I mean, you can technically have it on the stack as well, as long as you have a large enough buffer. You know, and yeah, it depends. I think that unless you need to worry about optimization, that is also not a thing you need to worry about. Like, just put it on the heap and you'll be fine. I think everyone has that, Blue. It's just a matter of training, like just practicing programming, and I think it's gonna happen automatically. I learned most from the coder space, the guys watching with AI voice. Oh, I see. Well, as long as it works, it works. Let's see. So we're on front end distance less than radius. So if it's like negative, that means the position has basically passed the line. If it's 0, it's on the line. If it's negative, it's past the line. If it's positive, it's still on the same side of the line, but the circle has passed the line, or is on the line. It's touching the line with equal. That's what I'm interpreting this as. And then we're trying to figure out, okay, we have two rays that we need to, two sweeps that we want to test. First is the starting sweep, and then is the end sweep. And we go to the start side is if the start is on front, then we pick the front, otherwise the back, and the end side is the other way around. If the first one intersects, we return that, otherwise we return the end side. And over here it's like we are on the same side basically, so we just need to check one of the sides. So yeah, that's the idea anyway. I mean, maybe there is something wrong over here. Maybe this is the path that we're taking, but something is wrong here. So here's basically the same thing, except we know that we have intersection. So we calculate the midpoint. So t is like, at what time do we intersect? So this would be the circle center at that time. And then we're calculating if we're on front, if the start position is on front. So we take, yeah, we're calculating using this thing here. How are we doing it here? We're doing the same thing, yeah. Okay. Yeah, so this is basically the same thing. Feel like we are making progress, but it's slowly but surely. It's really nice. We didn't have to switch methods, so that is very nice. But it's a little bit. It does take a lot of energy here to solve this issue. In this case, it's like we don't have an intersection, basically. We're on one of the sides. Wait, could it be this as well? We don't have an intersection. Both things are on front. I think actually the thing is, do we need to check, like, we're only checking if we're on front, like we're only checking like kind of like the raycast where we check only the point. We don't check the circle here either. If like, because here we know that, okay, both points are on the same side, because otherwise we would have an intersection. But we don't check if we're like overlapping onto. Well, actually we should have known that from this, actually. So we're not actually overlapping. Yeah, we're either entirely behind or entirely in front. Is that also true for the start position? Yeah, I think so. Yeah, so here we know that neither circle is like passing or intersecting with the wall. Okay, so I don't think we need to do anything here. This should be fine. How? I'm just gonna refill my coffee here. Right back. I think we'll go back here maybe. So let's think about this. So yeah, this is the end split here. I think the problem might be that we never get to this back side, this solid node here. And that was what I was trying to get to with the modifications that we did. The problem, like, we only want to get here if we actually intersect. So we don't want to split willy-nilly either. So here we know we have an intersection, so really we don't really need to do any kind of fancy stuff there. We already split. I think this should be fine. Over here is like we have already calculated that we don't have an intersection with the sweeping circle, so we can safely, I think, assume that we are on one side of the plane, the line, and that we can simply delegate to the correct side. So that should be fine. You we can just remove because you are deprecated. Yeah, I'm just looking up a thing here. 1 second. Cleaning up some tabs. What's this? Oh. All right. How to solve this issue? Right. I thought that this was the issue, like, because I think usually we go in here, especially if we split and the end section is like very small. The velocity is very small, probably most of the time. So when we split, it gets even smaller and we might end up over here. And we still want to check if we are intersecting as well. I mean, there might be something wrong with this calculation over here. End position minus the wall point, and then we dot product. Maybe we could change this here. So really also what we can do, instead of negating the normal, maybe that's wrong and bad, we'll make this mutable, and we have like if we're not on front, that means the start position is behind the wall. So then we want to check from the other side. Like we want to negate end distance. I mean, really, we could also just take the absolute value, I guess. Isn't that correct? We could take the absolute value of end distance. Yeah. No. Do-do. Nope, nope, nope. Okay, we can see the code path 176 a bunch of times and then 137. Can you please, what is taking so long? I don't understand why it's taking so long to exit. So 176, 137. Okay, so we're actually down here. Oh. Right, now we're already past. But that's weird because we should get an intersection because the circle should overlap there. Huh, that is strange. Unless we're already past... No, we shouldn't be. We should be intersecting... Hang on. So we take the distance, radius minus the distance. That is essentially what we are comparing with. And then the denominator is velocity on the normal, like how fast we're approaching the wall. Yeah. So it's essentially how close are we to the wall here, given the circle radius as well, over how fast are we approaching the wall. And if it's between 0 and 1, it means we've intersected. Maybe we need to check for intersection here as well. You know what? I'm gonna log here. And see if that happens. Okay, it happens like everywhere. Over here. Wait. What the hell? Oh, so this is kind of interesting. So basically, we can see here that it kind of works if we approach. Okay, that looks weird though. It kind of chooses the wrong wall. Where I think it's because this is prioritized, or it becomes later, perhaps. Yeah. So it's like, yeah, the path where the velocity is basically 0 works because that's what the one we fixed. But the path that does not involve that does not work. So I think we have our fix. We just need to implement it here. Okay. Now the question is, do we need to check both start and end points? Maybe we just need to check the start actually. So we'll do something like this. We'll take the distance of the start and we'll do the same thing basically here. If we are intersecting, we split. There we go. The problem is here. See how we're kind of moving. It's kind of cool because we can't actually go into the corner anymore, but we're kind of like, I don't know, sucked through this corner here. It's based on which wall we're considering to be the colliding wall, I think. If we do the same thing over here, yeah. But if we do from this side, there's no such effect. It's only from this side, and it depends on how the BSP tree is like constructed. Like which wall is prioritized, basically. But hey, one step ahead, one step further. Awesome. I mean, it might be a feature. But okay, cool. I think we're so close right now. So, how do we solve this issue? Yeah, so I think that regarding how Quake did it, again, if you collide against multiple walls at the same time, it's doing like multiple adjustments to get you away from the wall. I mean, maybe we can keep track of all the segments that we collided with. We could potentially have multiple splits that we need to worry about, not just the we could have multiple splits. The thing is though, you could potentially have splits that doesn't have anything to do with this wall. That's the thing as well. If we go to here, the overbounds goes, oh, it actually just uses the wall. I think we also need to correct that the position is kind of corrected, and then it's like, and we're recalculating the velocity. The velocity goes along the wall. And that seems to be fine until we get to a corner. The wall meets is gonna pick the other wall, which has a normal that goes like straight out. So the velocity is current velocity, and then we subtract the normal scaled by the thing. Wait, so this is the current velocity minus shouldn't we just set it to the normal? No, not the normal. Wait. No, we need to know which direction to move. Yeah, essentially we want to kind of normalize this and then scale it. So basically we have the new velocity magnitude is going to be the velocity dot product the normal. And then essentially I'm going to keep this to compare, but essentially this would be just be normalize the vector. No, this doesn't work. We need to set, wait. We also need to kind of rotate it to go along the wall as well. But essentially this would scale to the magnitude. But we also need to rotate it to go along the wall. I guess that's what we're doing here. We're taking this, okay, and we get the relative to or from the normal scaled by the magnitude. So if we go like this, the normal goes like that. It's gonna be the magnitude is like negative. So it's gonna be this minus that. So it's gonna be this. Yeah, okay, that seems to work. Are you seeing my invisible vector lines there? Okay, sure. The problem is that this normal is not always the normal that we want. Yeah, so okay, let's just try to do it how Quake does it again. So basically we take this, we do this again. I mean, we could actually do this in a function. Actually, so this is the try position, and then we should return the resolved position. So this should return a position 3, vector 3, and we get a try position here. And then this would be return. This we just return try position. Here we return this. And I guess we need the camera. We need root. DT. Okay, camera, root, wait. Root. There we go. Right, so we need to do this again. But yeah, so this would be so this is the first try, I guess. And then this would be the second try. So we'll do it twice. And then the result position is going to be this again with the second try position. And you will be result position. So we're doing it twice. And no, damn it. Is it like even faster now or something? Yeah, maybe we are not updating the position correctly though. Let's remove these things. Let's remove these. Okay. We might, it might be the overbounce that we are actually seeing here. Let's reduce the overbounce a little bit, so that might reduce the speed at which we're, I was gonna say moving through here, but that is apparently not the case. Now can you actually move inside? No. Okay, there's no crash anymore for being in the thing. Okay. I mean, you could say that it's a feature. Corner facing. You kind of get stuck. All right. Okay, so the overbounce made it kind of worse. It's kind of like we're ignoring this wall right now. So what is happening here is basically that normal is pushing us like forwards, I would say. Like we can still move forwards. Okay, actually, you know what? Maybe we can have a, this is stupid, but maybe we could have like an ignore list of walls that that is considered for the next iteration. Like the idea was that the physics would kind of correct itself to not be a problem, but maybe for corners this is different than for I mean, yeah, for like out, like convex corners is different from concave corners. Let's change the map actually. I would like to have, so we have cubes. Let's make the cube, you know what? I just want to add lines maybe. as well, so we can kind of make our own polygons. I guess this is a line, or walls, maybe even walls, probably a little bit better. I'm just gonna make a wall right here for now. So this would have start and end. That's it, I think, because the normal can be calculated from the thing. Yeah, so this could be, this is, if you imagine from the start to an end, imagine from the start you have a circle that goes around in a clockwise direction, and where it hits the, it hits the line, that is where the normal starts. It's gonna be like end is it end minus start, so that is the relative, and then we just rotate it by 90 degrees. Or is it negative 90 degrees clockwise, and then we normalize that. All right. And the cubes, yeah, I guess we can have a two-segment function, or we could just, maybe we could just make segments. No, that's fine. Okay. Well, it's only going to be one segment, so. Node, we don't have the node. ID, we don't have the ID. This, I don't think we have either. Position, we do have. Wait, position is the start. Yeah. Wait, no, that's the start and end, right? So, oh, okay. So essentially we could just do init, start and end. There we go. That was easy. Okay. And then the map to segments will just include walls, item, wall, and we basically just append wall to segment. There we go. So now we have those as segments as well. And draw. We will draw the walls. Wait, we don't actually do this anymore. So let's just remove that. All right. Yeah, because we're using the BSP to draw and stuff. So, okay. Now, instead of doing this, so essentially we don't have the cubes anymore. I want to do like polygons, but we can still say like number of cubes, so that's fine. And we still have like X and Z, that's the position of the thing. But the thing that we want to do is like, let's do generate polygon or whatever. This is going to be our kind of model that we generate. So it's essentially, maybe we'll just get a list of walls or something. Alright, so we allocate that. And we need a position. We get those walls, so essentially we will get the walls, the new walls. So let's generate the polygon at X and Z. We get a wall, and we actually, no, we can just say walls. And we append that. Wait, what's happening? Oh, I see. This creates a map. Okay, so this is map walls. There we go. Right, and you can be an arrow. So there we go. Oh yeah, the color. Actually, we don't need the color for now. And the eye is not used. Okay. So I'm thinking just making like a thing like this. Oops. So a thing like this. Just like this, so that we can, you know, move into here, test these corners. These corners, we can test these kinds of corners. I'm not going to do angled lines yet. I'm just going to try this basic thing here. So we need, we kind of could think about this as the outline of the square. So we need like, and then we're going to make like a smaller square, I guess. Put it at the bottom. That's going to be the outline of this. So that's gonna be like 3 plus 3 plus 2 walls. So in total there will be 14 walls. No, wait, no. 8 walls. Total of 8 walls. So we'll do the outer walls first. The outer walls are gonna be let's make an init function just for convenience. So start. Okay, so this position is the center. So let's define some points. We're gonna have like bottom left. It's gonna be position subtract size, half size. This is gonna be, I don't know, I guess 1. Wait, no, that's not correct. 10, I think. No, 5. That's half. Okay. And we're gonna have bottom top left. It's gonna be add. You know what? We can just do this. Multiply. This is gonna be -1, -1. This is gonna be -1, 1. Top right. 1. Wait, no. This is. Wait. Well, Y is flipped. Wait, is it flipped? I guess it doesn't really matter if they're all the same. But top right. So this is top. Top is. No. This is bottom. This is top, yeah. Left is minus, right is positive, yeah. So bottom right is that. Okay. We want a wall that goes from top left down to bottom left. We want, then we could continue on that one to go bottom left to, and this is the point that goes a little bit to the right of this. So I guess we could just say bottom left add inner or we could just say inner bottom left. Which would be inner half size. Which we could say is, I don't know, 4 point or 4.5, making the wall like 1, I think. Inner bottom left. So we actually need all of these for inner as well. So actually let's just do this. And that. There we go. Okay. So let's continue here. And then we have inner bottom left up to inner top left. Inner top left to inner top right, inner top right to inner bottom right, inner bottom right to bottom right, to bottom right. I'm just thinking if the direction is correct. I think it's correct. Bottom right to top right. And to tie it all up, it's top right to top left. And now we have a circle. Or, yeah. Anyway. Oh. Wait. calling this. Is that correct? Oh. Interesting. We get a crash immediately in the collision. I guess we'll disable that for now to see. Let's disable that. Just to see if it works. Wait. Okay, I think we have a couple of issues. They are on the. I think I made it the other way around, and there seems to be other issues as well. Bottom left. This is left. This is bottom. This is top. This is right. Bottom right. Yeah, that should be the same. So it should be that. Should it be the other way around? That's a little bit confusing, but I guess could we just flip them? I think we can just flip these. And it could be another issue as well. Okay, there we go. So now we can see that the. But this does not look correct, right here. But okay, now they're the right. Wait, what? Oh. Okay, I think the rendering of this segment looks weird. But the arrow is correct. Okay. So why is there a thing there? Did I forget something here? So bottom left, up to top left to top right to bottom right to inner bottom right. Oh, is it because it goes like up a little bit? Alright, so inner bottom left and bottom right are actually not correct. They have to be adjusted a little bit. So actually... unless... no... yeah. Let's just do this for convenience. So bottom left dot y should be equal to bottom left y. And that should also be equal. I think that was the issue. And there we go. Now they are correct. Okay. This was what I was thinking. Cool. So now that we have that, we can go ahead and try this again. Hopefully it won't crash. Okay, good. So it probably crashed because the BSP was freaking out because of the weird walls. So let's try this now. Okay, that looks good. Okay, the corners. I mean, we still have this weird bug. But at least now we can kind of test. Oh, this one. Okay, and this corner is freaking out as well because you know, why would it work? This corner. Okay, then you have priority. Okay, but what I wanted to check was these corners over here. You know, you're approaching the corner and hey, it actually works. So this case works. This case works. However, if the angle was more acute, I don't think it would have worked. I don't think it will work. It only works for these specific angles, I think. If they're more what is the opposite of acute angles? I don't remember. But anyway, if there were wider angle, I think we would run into the same issue as these corners here, because that's technically a wider angle, and we can see that we do run into this issue here. It's like it's totally ignoring this wall over here. Okay, but it at least it's like it's a little bit more stable. And the inner corners work. What if we just add one more? No, it doesn't work. All right, I just have to BRB 1 second here, sorry. Alright, I'm back. Sorry about that. So, let us proceed. Right, so we have the, whoa, what the hell? Oh, wait, I can't pass through there. I can pass through here, but not here. That is strange. I think it's one of these splits that makes it work like that. But we can move past over here. I guess because we're in a different plane dimension. Okay, but these corners work. Yay! Okay, can I pass through in... Yeah, I can... Okay. And these corners do work as well. Okay, cool. It's just this... There's like a... This line doesn't work, but you can go... You can get in if you do this. And then you face through there. Okay. How about that? Cool, cool, cool. All right. So we have to tackle these issues. I mean, maybe if we solve one of these issues, like maybe if we solve this issue first, like this one, where you can't pass through here, maybe if we solve that, maybe the other one solves itself. I see, there's like, yeah, because we're moving into this wall at the same time. Yeah, so essentially we have trouble. Well, this one is an issue, but we also have trouble with multiple walls that are concave. Like this convex configuration works perfectly, but the concave ones does not really work that well. Because I think this wall has priority, so this corner works, but then this corner does not work because we're kind of going into here. Maybe we can try... I mean, we could try to see if we could potentially get the wall that collides first, instead of just randomly pick one based on how the BSP is configured. So we try to pick a wall that is that we actually encounter first. The problem though is that I'm not sure if we have that information. I mean, we know that this wall is prioritized because this is the wall that we're checking last. So we're splitting through that one last. That becomes the new splitter. The problem also is how the BSP is arranged so that this wall... I mean, we could also do it like this. We can get which walls are we intersecting through getting all the IDs of the walls themselves. Because then we can actually do we can do a brute force check against those walls. Once the BSP gives us a list of all the splits, like a list of all the walls that caused a split. But the problem with that is we get this kind of effect then, that we will get some kind of, yeah, you split this wall, and apparently that is an issue here. I wonder why that doesn't happen over here. Yeah, because the idea was that maybe if the BSP could help us to just select these two walls that we're intersecting more efficiently, then we could do a full-on brute force algorithm on those walls to figure out, to better get the actual correction that we need to do. Instead of getting a bunch of infinite planes, we get these actual walls instead. If we could use the BSP for that, that would be great, but I'm not sure if we can. That's the problem. The question is, why would we actually get this intersection here? Also, if you look at the split, this should split this one, I think. Or maybe not. This is the root. The root splits this over here. So this part over here is behind the root, and this part over here is in front of the root. And then I'm not sure which wall comes later, but we can see that this wall is split from this inner wall here. This wall is a child of this, I think. But why? So I think these walls are ultimately the end nodes, because they don't split this wall here. Yeah, why are we getting this collision here? And even over here. This wall splits that. Wait. This is split over here, but not over here. That is strange. I don't think that should happen. Unless I'm thinking about this. No, we get a split here. It should split through the whole plane, not just this part. It should split this one as well. Oh, it might happen if this is exists in a different space though. Right. Yeah, that's true. Okay. And here we get this. I mean, it kind of feels pretty. It feels kind of stable, like it. You know, of course, it doesn't follow any kind of weird rules of physics, but it does feel stable. Like we don't get crashes. It follows the kind of rules of the world. So you know, you could technically consider this a well-defined physics simulation. Alright. And you just find these little, like, how do you get through here? Technically we could design a level that actually works with these physics. It would be a pain to get it working though, especially, you know, given the randomness of the BSP and all that. And this might be a problem, like this extends infinitely over here. Yo John, finally I can compile my C code with Nix. Oh. Awesome. Are you... I've never used Nix. Like for the longest time I didn't even know what it was. I mean, I won't pretend I know what it is now either, but some kind of automation suite or program or something, I don't know. So what do you mean when you say like you compile it with Nix? Is it kind of like a make file but using Nix instead of make? Okay. Cool. It's a package manager. Okay, so but it can be used to write scripts and stuff as well, or? I actually don't know. Well, I can show you because someone did Nix thing for my Runic language. Description language. That's too much credit here. I don't really. I think that's AI generated. I mean, what language is this? Nix own like configuration language. With Nix you have to specify binaries and libraries that you use, right? Yeah, okay, well that's cool. And but then it looks like, okay, so we define some stuff. We have some, so this looks like a keyword thing. Self Nix packages, okay. And you have a little bit of magic here as well, it seems. So we have like system is that, packages is this. Interesting. field access syntax. And then we have packages system equals I use bare nicks, not even flakes. Okay, well, this is way over my head. I don't even know what the difference would be. You can even replace Docker with nicks. Okay. You kind of have to make a contained environment to compile things. Yeah. Sometimes I feel like the people went a little bit overboard with the whole contained container things. It's like, yeah, it could guarantee that. Sometimes it doesn't even guarantee, but it can guarantee potentially, you know, that you can build something correctly. But then it's like, I think it's like overused. I don't know. It feels sometimes it feels more of a hassle than what you get from it. So making a system that like makes it easier to work with those things, I think is really nice. Make derivation, standard and make derivation. So are these like magic things? P-name version, like default packages. This follows like a schema. Source equals self. I've heard of NixOS, but I don't think I understand what it is. And it's like, if you compare it to, let's say, NPM, for example, Node's package manager, the only thing they really need to kind of guarantee that you will get the same output every time is basically that you're using the same node version and you have the versions defined in such a way that it's always going to be the same. And then they also use like the package lock file that kind of locks all the sub dependencies as well. And that's it. Then you don't need like an entire container to install things in that sense. It just seems so like overboard sometimes. Although it does make sense if you want to deploy something, then I think it makes a lot of sense to use like containers, but also sometimes, you know, not. If you want to set up like a more optimized thing, I don't know. Flakes have lock too, okay. Yeah, because here there's a bunch of commands, you know. So essentially, it's like a make. I mean, I see this as kind of like an advanced make file or something like that. With, I guess Nix has a bunch of built-in magic things that you can do here. And maybe also, does it read this file? Like if you want to install this repo with Nix, or how does it work? Then it's gonna read the flake, and it knows how to do it or something like that. Oh, it even has this, okay. Well, Okay. Well, anyway, whoops. Here we can more clearly also see that the walls that we don't face are not drawn as well. So I want to fix this issue. I'm not sure how though. This seems different. This is a different issue here. Change Conf Nix OS. That's pretty much everything in one place. Okay. I mean, is it an operating system? I mean, it has OS in the name. Or what? Or is it like Docker? Just don't use Nix as a build and deploy system unless you have time or you care about containment and crazier things that I don't understand. Right. Yeah, I don't know. I just feel like I don't really have a need for it. It's just, it feels like it's solving some kind of problem that I don't currently have. Maybe if you kind of learn how to use it, it could be nice for some situations, but I don't know. All right, I'll bang my head against this a little bit more, and then I'll call it, because I'm running out of energy here to fix this issue. But I feel like we are moving forwards, but it also, now it feels like we're moving one step forwards and then 2 steps back. But yeah. I was thinking, now sweep circle. I don't think the acceleration matters. I'm just gonna ignore this. The acceleration is basically, it's just to get an extremely precise position on where you would end up. But I think the velocity is the only thing that matters. We have a start position and an end position. It's just to get like an extreme precise point on where you would intersect with the wall. But I think that doesn't really matter. It probably doesn't really matter. So let's just get rid of those things. Oh my god, this algorithm here starting to become quite a beast. So I'm just adjusting here. All right. So what could be happening? Feels like we're ending up on like the wrong side of something. we end up on the wrong side, and in the end it's reporting a collision because we end up on the back side of something that is solid, and that we shouldn't because we are not there. And it seems to happen if we have two of these. I'm gonna do this. I'm gonna make a new thing that is a little bit larger. And we're gonna draw on this instead. So we basically have two of these. And these ones were going out like this. Of course. Essentially we should have like two of these planes. But that's fine. Yo, Mutasimos, what's up, what's up? You're adding texture packs to your voxel game. Oh, awesome. Well, yeah, how's it going? What's I was thinking, what was the feature you added last time? Okay, so then we have the player moving. Here's the player. Oh, sorry. Here we go. Yeah. Okay. So I'm trying to show the. I'm trying to show the map here. So this is how the map looks. Basically, we have two of these things. These I think are considered like further down the line. So we have this invisible kind of split over here, and we cannot move past it. It's like it's saying that this is a collision. You are not allowed further here. Oh, you add a third-person perspective. Oh, cool. Are you planning to add? Are you planning it as a long-term project, or just like a educational project? I guess it could be long-term educational as well, I guess, but do you want to make it into a game? Okay. I'm just trying to understand what could be happening here. There could be like a slight overlap to the thing that's behind here. And actually, you know what? Now that we actually do get a positive on collision, we could log out the path that the collide. We could log out the path that was taken to get that collision. Actually, so let us do that. We have let's do like, I don't know, log is an array list of strings. And we are I'm gonna try and log the path that was taken. And here we're basically I'm just gonna log this out. So there we go. Sort of educational, sort of long term. Awesome. First thing related to Mindplace was on October 2024. Oh yeah, wow. Yeah, I'm not sure if you answered this, but do you have like, can you destroy the blocks? Can you like add and remove blocks? So is the world like dynamic? Okay, so here we are. So here I'm gonna say that we do log actually, let's add this. I'm gonna add this as a function. And section info format is a comp time string and an args anytype. It's just gonna be like self log append and s is gonna be standard print format. There we go. And then here we can just do log, and then we can log whatever we need. Yes, you can mutate well. Awesome. Oh yeah, it was written in Rust, right? Or do you have any multi-threading? Oh, shoot. Let's store an allocator on the thing instead. Returt. It's a weird keyword. just so we don't explode with memory leaks here. All right. You know what? Actually, catch, we just return. There we go. My allocator. Do we have an allocator? No. Okay. We'll pass it along. I think we should have an allocator. No? God damn it. Wait. There we go. Alright. Yeah, Rust. Because of safety. Rust, not because of safety, but because I really like the features. Alright. Maybe I'll switch to Haskell one day. Try to go ultra nerdy. All right. Okay, so where are we? I think the overbounds needs to be larger, maybe. Yeah, there's like a small noticeable kind of jittering, but I think like when we're going around the corner. Oh shit. Okay. I think this might be because we're kind of colliding against a lot of walls at the same time. I don't know. The speed at which we're moving past the wall, I think, has to do with the overbounds. I think maybe if we solve like the directional issues, this issue here will solve itself. Okay, what we're trying to solve is this issue. I'm trying to move in here and we get stuck. This part we can move in and it works all along. It's these corners that are the issue, and also now this part as well. And we get these logs here. Okay. I'm just gonna test this here. So if we move here, we move around, and we move there we should get collisions. Huh. What the hey? Oh, I see. We simply haven't logged that out. Also, what I would like to do is change the player position so that we start on that side. Where is that? Where is that defined? I think no. It's the camera, basically. Where is the camera? Here is the camera. And here's the position. Let's do that. Will we end up like in one of the cubes? Yeah. So let's do like, I don't know, 13. Whoa. Let's do, I guess, 15. And then I want to look behind me. So direction is going to be -1. What? So your it's your pitch, right? So this would be, I think it's based on radians. Wait, degrees to radians? No. Okay, it's degrees. So your would be, I guess, 180. Yeah. So there we go. We're placed right at where we want to be to test this scenario. Now, so Mutasimus, like, do you feel like, but you're not feeling like Rust is like hindering you? You feel like you're flowing with Rust to make it work. Wait, what the hell did I, what? Collision. Yeah, okay. So now we wanna log out all the paths that the algorithm takes. So for example here, we're kind of moving parallel to the, or either the velocity is very low or we're moving parallel to the wall. So I'm gonna say like change in distance to the wall is low. But here we do a split. Here, change in distance is low, no split. Here we simply split because of intersection. Over here, I'm guessing this is the part that's wrong. We split based on intersection, even though at this point we should be fully behind or in front. But this is essentially, I'm not sure what to call this. This is split when, even when no intersection, I guess. We'll call this. And this is no intersection. I also would like to log out the number so we can see when it ends and starts. Okay, we have change in distance is low, so no split. Okay, and then we have no intersection, and then we have 2 splits. I mean, having a split makes sense, and having them at the end makes sense because those segments are seem to be pretty low in the tree, and they span that space. So having a split makes sense. However, their solidness is an issue. I think this is like a fundamental issue with the BSP tree that we have, that we need to solve. Sometimes Rust is annoying, but most of the time it's good. Okay. I mean, yeah, it's the same with Zig, I guess, but it's mostly to do with memory issues that you would probably get in any low, like manual memory managed programming language. Okay, so I think that we have like a fundamental issue with our BSP trees, because I was kind of assuming that the last node or maybe it's a fundamental issue, maybe not, because I was assuming that the last node, if we're trying to compare against this node, we are actually always going to be over here. I'm gonna draw these out. We'll have green and purple or something. All right, this is the root node. Whoops. Wait, why are you not? Oh. Well, actually, let's make another layer here. Oh man. Okay, whatever. It doesn't matter that much. There we go. This is the root node, and you can tell it's the root node because it's spanning the whole map. That's the root node. You can kind of tell. And then it's divided like these are in front of the root node, these are behind. So the behind actually doesn't really matter in this case, so we could skip those actually. And then I think these are pretty low in the tree. It doesn't really matter which ones we should choose. So basically I think the one that's starting is this one. So I think we'll pick that one. Or maybe it's this one actually, because why would this be the root node? I think, yeah, I'm thinking of this in like the other way around. So let's do a purple. And then this is, okay. Actually, you can't really tell this is a root node because this spans the whole thing and this also spans the whole thing, but okay. Anyway, so, and then maybe this one, and then this one, and then I'm not sure, maybe this. I don't know actually. Okay, let's just take this one because I feel like it should go around like this. It might do the other way around, but so that is one segment over there. But then this actually has children, so it should probably be this one. And now this one splits. This, no, it doesn't actually split this wall. But it should go up here like this, actually. I think. I think it goes up like this. Which is kind of weird. I don't know. And now we got this thing here, which goes like that. And then we got this, which goes like that. And then we, at the end, we kind of got this one, which is like splitting like this. I think this could be how it looks. Maybe. It's kind of hard to see which is like a child of the other though. But this is the root node. And then this is, so essentially if we're over here and try to go up, first we're seeing that, okay, well, we're in front of that. We're behind that. So we're in this section. Next up, I think, is this one. We're behind that, so we're in here. We're behind this one, so we're over here. And now this one. So we're actually in front of this one. But we are trying to intersect here, so it should like spawn one in front and one back in the back here. So we're on the back side, which involves all of these, and we're in front of all of those basically. So we should end up in like in front, and then we have this one, which is interesting because we are intersecting that one, so we're kind of ending up like behind this one and in front. And since this is like the last thing, is actually denoting this part here, which is a solid, so okay. We're kind of back to the drawing board on these BSP trees, I feel like. I thought I kind of understood them, but maybe not. Maybe... No. Maybe the geometry has to be like convex for it to work. Do we have to split up the map in like convex geometry first and then create a BSP tree? I don't know. How would that work though? Would we have multiple BSP trees then? Or what? I'm trying to like make my brain understand the issue and solve it, but nothing's really happening. Am I missing something obvious here? Because it worked well when you had two like convex, you know, shapes or cubes that were separate. But now we have like, you know, a concave thing. Maybe that's the issue, but I still don't see. I still don't fully understand how we could solve the issue by splitting things up. Maybe if we made like, I mean, another segment over here, like walls here to make it convex, or I mean concave. Which shouldn't we still be like have the same issue? Like instead of if we had these as blocks instead, like a one block here, and one block here, we should still have the same issue. I mean, we can try to make that configuration, although that might mess up the order of things, so we won't get the same situation. Because I think in order for this to happen, these nodes need to be like very low. Okay, hang on. Let's see this again. So we're in front of this, we're behind this, we're behind this one, we're behind this. Next one is this one, I believe, which we do intersect, so that is the split. Right. And then we're basically, I mean, we're in front of this. And next one I think is this one, which we're in front of as well. So now we're in this area. And the next one is this, so we're in front of that. But this one is behind, so we shouldn't even try against this one. Yeah. And then the back, and then in front of this should be an empty leaf. So I mean, this is probably not the configuration then. We have a split there. It has to be this line splitting there. So this is the root. Wait, oh, the root is like inside here. Well, it doesn't really matter that much though. All of these are behind the root. Or on one side of the root, anyway. And then we might be looking at this one, or I think that one. Because that seems to be the first along the way. But then this would be split, and it's not. So I actually don't really know what order this comes in here. But if it's in the order that I stated, I don't see how this is an issue. It shouldn't be an issue, like we should be able to go through here, but I mean, there might be an issue with I mean, of course, yeah, there's an issue with the algorithm, of course. So we got 3 no intersection and 2 splits. Same thing over here. Two splits. So how could it happen? Like we are on both sides. It might happen if we get on the wrong side of one of these nodes by mistake. Because then you can have weird stuff happening. Like if you get on the backside of here, then you would get an issue, or here, I guess. But I just don't understand how that is happening. Man. We could log out maybe information about which node we're in. We have a format. You have front and back, which are nodes. Wait, oh. I would like to kind of format these, like maybe show start and end points. format line. So essentially this would give us a formatter, so line formatter. And essentially it's just a thing like this, and then you would have I guess the node here. Actually, this is the branch. Wait. Yeah, fine. The branch. And then we can format it however we want. This just returns branch equals self. There we go. And then here, now we can have a different formatted function. And we can say, you know, we'll say print. So we'll just print start and end. So actually, let's do it like this. So this would be branch p0 x y. This doesn't have z, that's right. p0 and p1. Okay, and now you can go here and we can actually say f still, and then node.branch dot format line to give us the formatter. And we can do the same thing for all of these. Was that all of them? Yes. So just move forward. We get the thing. All right. Change in distance low, no split, no split, no intersection, and then split split. So we've got bottom left. Wait. X is the same. Y is different. This should be like the root node here. Or, yeah, because every path is logged. So this should be the root node. And then it goes down the tree. And we end up with two splits over here. It's kind of hard to tell which line it should be though. So I want to try something. Like if we remove one of the cubes, can we still get the issue happening? No. You're doing mass refactoring? Is that because you're using Rust? I'm just kidding. So yeah, this should be. We get the exact same issues. You know what we could do is show the ID of the segment, because that gives us a little bit of a hint, maybe. And we can actually just include this over here. And this will be the segment ID. And so the root node is always 0, and then we jump over to 7, which makes sense because the first cube, or the first like walls, actually it should be like 8 of them. 0, 1, 2, 3, 4, 5, 6, 7. Isn't 7 the first wall of the same then? You have 3 outer walls, 3 inner walls, and then 2 corner walls, or whatever they should be called. So that's 8 walls. So 7 doesn't actually make sense here to me. Zero, because that's like the last. Wait, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, that should be like the last wall of the other one. No, wait, it does make sense because it does make sense actually, because that should be behind the root. Yeah, I think it's the long wall that's behind the root. Yeah, probably. Like, I think it's, if we look at this, the root is that, the purple one. This, I think this is the 7, this here. But also that doesn't make sense. Maybe it's this one actually. Maybe this one is 7. Oh yeah, the tree is balanced, so maybe the IDs, we can't really rely on those for the order. No, it's because I'm moving fonts and the GUI atlas to assets. Oh. Oh yeah, did you see? I'm not sure if you saw that, but in my game and the editor, I made like a Zig ComTime thing that kind of loaded all the animations, so the animations would have like auto completion in Zig. Like the Zig would actually compile with the names of the animations at compile time. That it was known at compile time, and it was just reading. I don't remember exactly how it did, but I think it's just reading like JSON files and then compiling those with Zig. Okay, so I'm not sure which one is happening. Maybe we could do it like this. Maybe we'll record like the sequence of which walls are being like checked. And once we have a collision, we store that sequence, and then we kind of loop through the sequence to see in which order the walls are checked. Yeah, it was insanely cool. I mean, yeah, I mean, it is nice. You get like, compile time, and also you could turn the names into the field names. Like the animation names actually became fields in a struct. So you could type like, dot walk or idle or whatever. It would be kind of imported from the animation. So if you updated the animation from the editor, you could it was automatically like updated in the code as well. Or I mean, it wasn't updated, like the code didn't change, but basically you would import, like re-import the, when you compiled, it would like look at the new files, the new JSON files, and it would compile with the new things. So if you updated the editor files, if you saved the animation to create a new animation, saved it, you could get, if you edit the animation name of an animation, you could get a compile error when recompiling. That's what would happen, I think. Okay, now let's see. We'll go back here. Intersection info. So, what we want to do is I want to store kind of the node path that was taken. So, node path. Let's make it into an array list. And I guess we could just have nodes, to be honest. Okay. And initialize, it would initialize, do that. All right. And whenever we log, we also want to store the node path here as well. So add node node. ESP node self node path. Oops, append. I'm just gonna cache return. Right, just append node with allocator. All right. I'm rewriting so much stuff that I've given up on proper indentation. Yeah. Why indent it to format it can do it for you? Yeah. That is true. I mean, I'm so used to it, so sometimes I do it anyway. It's just, I don't know. I have some kind of OCD on that one, but Zig also has like, say format, a built-in formatter in the compiler, so. Or in the Zig program. Okay. Wait, what the hell am I doing? We are doing this, yes. So simply copy paste this thing there, there, there. There we go. And I actually really like having like a program format for you. If it's a good formatter, like you know, a long time ago we didn't have that fancy stuff, so you had to kind of make up your own formatting. You spent so much time formatting your code, and but then I think Visual Studio had this auto formatting thing, which was kind of the worst formatting I've ever seen. And it was super annoying because everyone kept using it and you would see this weird formatting in the code everywhere. So yeah, just you had to get used to not trying to format every little thing. I had this, you know, muscle memory basically when I did some things to format while I was typing, but sometimes you would lose a lot of time if you gonna rewrite the stuff anyway and stuff like that. So, but yeah, basically, you know, typing something, doing something like this and this, and then I would like, I think, man, I don't really even remember now. I would basically go back, do something like this, you know. I'm glad I don't have to do that anymore. But yeah, Visual Studio formatting, like the initial, like the thing they have, I think they've improved maybe on it now, but the thing they had for C#, I think, it was really atrocious formatting. Okay. Right, so now we have this list. So now we can go out to main and we will create a little thing here. I mean, we do have this that we can keep around, perhaps. No. Let's just make this collision. Node path, which is essentially just a list of VSP nodes. Start with an empty VSP node. All right, and when we do a collision thing, where is that happening? Here. We want to pass in this over here. So node path. I want to pass that in so we can, so it can get populated. Like this. Okay. And oh shit. Right, we have two of these. Which one would be? I mean, I guess we would take the first one. really, like, it's in here, we want to update it. I think what we'll do is we'll null this, and we'll say if, whoops, if we have one, we want to set it to be section info node path to own slice. I'm just gonna catch unreachable. Right, and then for the first one we'll do this, and second one we'll not do it. Okay. Alright, so now we should be updating that. So in main here, this should be populated with the path. And what we're gonna do is we are going to here we're going to draw node collision node path. Node collision node path. Alright, so we're gonna get T. We are going to get N, which is how many, or which one are we on? I guess I could use. So this would be like this would be like mod, and then we have floor T mod, and then we do like int from float as use size, and then this would be length plus 1. Okay, so that's I. If I is equal to 0, we return, and then the actual I is going to be -1, or this is J. So that's the actual index that we're going to draw. Now, how do we draw this? Actually, well, we have the node actually, so the node, well, actually we can just say node here. Node is equal to collision node path with this index here. Now we have a bunch of stuff. We have the branch. So if it's not a branch, I think it's gonna be hard to actually visualize the leaf, because the leaf does not have any information about space. It simply is solid or empty. So we only consider branches. So if node is not equal to branch, we return. And so we have our branch. And here we have a bunch of stuff. So we have the start and end points, and we have the normal. So we can draw this segment. Do you even have like a draw function? No, you don't. We can get, I mean, we can get the segment But I mean, we already have the splitter stuff, so we could do start is vector3 start 2D is node branch. I'm gonna say P0 is node branch splitter P0. That's the start. And P1 start is P0 X 0 P0 Y and same thing except P1. Alright, so that's start and end. Wait, what did we do for segment? Oh wow, there's a lot of stuff happening in here. Oh yeah, it depends on the play position and stuff. If we're on front, we have the center, size, color, size. Oh yeah, we could take that. Size would be like end subtract start, and then add one, I think. Then we can draw this thing. Okay, yeah, because this is the arrow. This is the thing. Right? Draw cube. Let's actually just draw the cube. Like this. Right, we need the center. Center is start, add okay. Wait, you're vector 3 anyway, so that's center, size. This is gonna be, I don't know, yellow maybe. Okay. Let's see if it works. We'll go in here. Okay, so we're seeing that's the root. Interesting. So it goes root, then that one. So we're behind both these, and then goes there. We're in front of that. Yeah. I mean, it makes sense, but it doesn't. It also doesn't make sense. So behind, in front, front. Actually, it's a split on this one. Yeah. Okay. I mean, I was hoping for clarity, but I have not received it yet. Is anything happening over here? No. Which makes sense. Right, so what's happening is like, first it's going to the root node. We're behind the root node, so next is the child of the root, which is behind, which is that one. We're behind that one as well. So next one is this, which we are in front of. Yeah, because it's the front, is the one facing us there. And then it goes to the child of this, which is apparently this one. And we are intersecting this one. So I guess we're splitting that. And then we also split this one. And behind this is solid, so we stop. But why is it working like that? That's the question. Oh, nice. Yeah, first step, get rid of errors. Now, fix all the issues. Fix all the runtime errors. Is it just like it's a scenario that always fails here? Let's see if we can make sense of this over here. So I mean, this is the root node, but it doesn't really matter. We still split over here. And then apparently this was the next node. It also doesn't really matter. And then we end up in front of this. And then these were apparently the children of that. Or the first child anyway. And then this was, I think this was like in front. So it's gonna check that first. And then there's apparently then, I mean, yeah, there's an intersection of that thing. Okay, let's try and actually create that order, because that might have significance. So first we'll start this one was the root. Points over like that. Okay. So that was the root. Then I believe it was this one it took as a back child. Okay. Maybe it's better if we just alternate the colors. I believe next was it this one? Maybe it is, because it kind of follows a pattern. Maybe it has to do with the balancing. And then it was this one. And then it was this one, which kind of splits like this. And then this one is also in front of this. But the idea then is that we would continue with the, like, this one I think is like in front of this one, because this is a child of this, because it's like on the same line, so it should end up in front if it's like handled later. But the problem, I mean, and then, but the idea then is that if we are, and if we want to check on the back side of this, we should have more children to check than after, because we haven't checked these ones. So that's the idea. So even if we cross this line, we still have to check like these ones, which we don't intersect. So that is a little bit confusing to me. Okay, maybe we could add more information. So we have the node that was the actual the split that we are colliding with, which should be like the last one. That we can actually see that from the logs. What else can we do? Yeah, we could add at the end here, we could add the node that was the last split to the list, so that it kind of shows like, okay, well, this, we ended up with this one. Okay, let's check that first. What? Oh. It should always be there, so. Ding, ding, ding. Wait, it disappeared? What? Did you? I'm confused. No? Okay. What the hell? Here we go. Boom, boom, yeah, so that is the last split there. I'm also gonna do, when we draw the last one, so we'll do like color if I equals length, then it's gonna be like purple or something, I don't know, cyan. Wait, what do you have? We don't know. Else, yellow. Is cyan a thing? No. Turquoise. Red is a thing? Okay, fine. How's it going, Mutzimus? Yeah. Boom, 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 boom. And that's the end of the split. Okay. If you say so. So then we know that. What else can we get out of this? So it's checking the front of that one. So we're checking the front of this one first, which is gonna collide with this. Which apparently, I mean, I think it would help if we knew the whole tree. Because then we could pinpoint, we could go through the whole thing and pinpoint where the problem is. But yeah, this is the front child of this. This is the front child of this. But these should also somehow, like these, it could be like this is the front child and the back is, you know, a leaf. And apparently, I mean, yeah, that's a solid leaf. But the back of this is gonna be these two. Right. But then we never check those because we end up checking the front of this first. Okay, actually, is this an issue with the ray as well? Yes, it is. Okay. Except over there. Huh? So it is actually an issue over here as well. Wow, okay, so it might be like a fundamental issue with the BSP tree then. Okay, you know what? I mean, it kind of feels like I should give up on this, to be honest. I don't know if it has something to do with how the level works. Like if you only could work with like convex objects, but even if we had a bunch of convex objects, we could run into the same issue again, I guess. Is that the case? Let me look this up here. Does BSP trees only work with convex geometry? It sounds weird that it's... They're designed to subdivide space into convex sets. So that is correct. They can represent complex. Okay. Wait, handling concave polygons. While convex polygons are easier for BSP tree construction, concave polygons can be handled by splitting them into smaller polygons. So are you meant to split it up before then? BSP trees use convex decomposition as a method to partition space, but the resulting representation can accurately describe non-convex. Hang on, let me... I'm already doing that. Method for space partition will recursively subdivide Euclidean space into two convex sets by using hyperplanes as partitions. This process of subdividing, and here we can see an example. I mean, this looks very convex. Wait, convex or concave? Concave, I mean. I think. Anyway, it's dividing in half. Okay, this looks nothing like what we're doing. Okay. Oh man. 1969. Structure is three of the readers. Yeah. History. Overview. Partition planes are frequently chosen to coincide with the planes defined by polygons in the scene, yes. The specific choice of partition plane and criterion for terminating the partitioning process varies depending on the purpose of the BSP tree. For example, in computer graphics rendering, the scene is divided until each node of the BSP tree contains only polygons that can be rendered in arbitrary order. Right, when backface calling is used, each node therefore contains a convex set of polygons, whereas when rendering double-sided polygons, each node of the base picture contains only polygons in a single plane. In collision detection or ray tracing, the scene may be divided in primitives on which collision or ray intersection tests are straightforward. Yes. You are correct. I mean, I might just be building the tree wrong. Maybe we need like a specific tree for collision detection instead of what we're doing now. I don't know. It just it feels like we followed like this guide, and it seemed correct, but then we end up with issues. I mean, it might be my code that's the issue, obviously, but yeah. Show that goes to be the disadvantages. Generally, the BSP can be time consuming. Typically, it's therefore performed on standard geometry. Yes. For rendering polygons. Yeah. Traverse. Okay, I don't know, man. I might be done with BSPs. It would be cool to make this work. I mean, it feels like we're very close, and it kind of works pretty well. But I don't know. I would actually like to see more modern algorithms as well for like 3D worlds. That would be kind of cool. And yeah, trying something else. But I also would like to get back to my Metroidvania game, so maybe we'll put this on the shelf. It would be cool to kind of make this work. You know what we can do? Actually, we could do one more test here. We can test if this still works if we just do the cubes. Like, we'll do the cubes instead. We go back to the cubes. And we'll just increase the number of cubes. I'm just gonna do this to see if it works still. Yeah. So this still works here. We still have this issue here, but whatever. Which we probably still need to solve to make this work, but whatever. And then I want to go to main. I just want to see if we get an issue here, because I want to see if we generate a whole bunch of cubes, if we get some kind of weird collision issue with that as well. Because it might have something to do with things being concave, or it might just be an issue with how I'm building the BSP tree. So let's do like 20 cubes in like, I don't know, 50 by 50 area. And I'll reduce the size of the cubes. Where? Yeah. So you are. So let's do, I don't know, 3. All right. Okay, so here we have a bunch of cubes. They're kind of weirdly spaced out. And here you can see we already ran into an issue with some of these spaces being strangely cut off here, depending on which kind of space plane you're currently in. So there is a general issue with this collision detection algorithm here. And I don't really know how to actually fix that. So, and I don't know how much more time I want to spend on this. But it's kind of sad, because it felt like we came so far here. So, but I do want to get back to my other project. But this was fun though. Like the BSP, I mean, It feels like we failed a little bit. There's like some kind of understanding left that is kind of lacking with this. It was way more complicated than I thought it was from the start. And I mean, obviously it still is also something. It feels like it should be something simple. Like it should be a simple solution to this issue. But yeah, I think we'll leave this. I think we'll leave the BSP for now. I'm gonna push these so it's updated. And maybe Blue, you can fix this and report back to me what the issue was, because yeah, it would be cool if we could get this to work and make a little mini game out of it. But yeah, I think next time I will try to actually get back to my Metroidvania game. We'll see. Maybe I'll do like a smallish thing in between, but we'll see. Okay, but yeah, that's gonna be it for this time. So thank you very much for watching, and